Hi there, welcome to my channel. In this video, we are going to solve this particular problem. And the problem is to find the depth of the binary tree, and we have to find the maximum depth. And maximum depth is the number of nodes along the longest path. So in this particular diagram, you can see this is the longest node. This is the longest path along the node. And you can see we are going through 3 nodes. So this is the maximum depth. So let's say programmatically how we can solve this. So let's say the approach first. So to solve this problem, we just have to traverse the tree. And this tree traversal can be done with DFS, which is breadth first search, or DFS. So you can use any of the algorithm, any of the BFS or DFS algorithm to solve this problem. So in this particular video, I'll show you a DFS approach, one with recursive solution and another with non-recursive solution. So let's get to the solution. Let's call this function find depth, and we'll pass root node. And here, whenever you try to solve a problem in a recursive way, you always first try to solve it with 2 levels, one with the bottom one and one with the top node. So we'll just consider this particular tree to solve the problem first, then we'll see a holistic view. So in recursive program, we always have to write a termination condition first. Here I'll give if root is equal to null, then I'm going to return 0. So if you see here, this particular node has a depth of 1, but below this there will be a node of null. So the element below this is null. So the depth of that element is 0. So if you see, we'll have something like this. So we'll have the null elements at the end. Similarly for this one. So what we're doing for null elements, we are returning depth as 0. After that, we are doing DFS. First, we'll solve the left side, then we'll solve the right side. So we'll just call the same function again with left node, and we'll do the same thing for the right node. So after this statement, we'll get to know what is the maximum height on the left side and what is the maximum height on the right side. So based on that, we'll calculate the depth. So whatever max we are getting, we'll take it here and we'll add it with 1. So suppose for this particular one, on the left side we have a height, we have a depth of 1. On the right side as well, we have a depth of 1. Let's suppose 7 is not there. In that case, we'll have a left side depth as 1 and right side depth as 0. So we'll take the max of it and we'll add it with 1 and we'll return it back. So that's it. This was a recursive solution and this was quite simple. The similar kind of thing you can do in DFS as well. For now, this is the recursive solution. Now let's see the non-recursive solution for this particular problem. So why to know the non-recursive approach? Because in recursive solution, we have a limitation because we have a limitation in stack size. If it reaches the maximum memory of the stack, it will give you stack overflow error. So better to know the non-recursive approach as well. Let's see it quickly. So here also I'm going to write a simple JavaScript function and I'll call it with the same name, and we'll have a root with us. And in recursive, by default, we use a stack as a data structure. So here also we are going to use the same data structure. I'll call it stack. By default, JavaScript doesn't have a stack, so I'm going to use array as a stack here. So we'll create a stack, and by default, we'll pass our entry. We'll pass this root with a depth 1, and we'll maintain one more variable here to calculate the depth. I can call it res. After that, I'll just pop through the array. I'll just go through the array. If it is not 0, then I'll keep iterating this particular stack. And in each iteration, I'll pop the element from the stack and I'll assign it. Let's create a variable node and depth. And here I'll just pop the array. After that, I'll just check if node is there, because node can be null here. If node is present, in that case, we'll calculate the depth, and this will do by taking the max of result and this depth. I'll explain this why we are taking max of result and depth. After that, we have calculated the depth, so we'll just push the left side and right side to the stack. So same thing is happening on the recursive function as well. So we'll do stack dot push root dot left with depth as depth plus 1, and this will be an array. Same thing we'll do to the right. Yeah, and after processing, at the end we'll have our result. So we'll just return it. So let's see why we are doing method.max of result and depth. So this particular solution is a DFS. That means we'll be traversing one side first, then we'll look into the other side. So first it will traverse this side, it will calculate the height, and it will keep it in result. On the second type, this will go to the right side and it will calculate that. So there could be a case that this RES, this result, is greater for the left side or maybe smaller for the right side or vice versa. That's why we are doing method.max. So I've given you two solutions, one with a recursive solution and another with non-recursive solution, and both are quite similar. And this both are DFS. We are doing depth first search. So same thing, you can use a BFS here to solve the problem. And now let's talk about the time complexity. If you see here, we are calling the same function for n times. And if you see here, it's clearly visible that we are popping the stack. And in this stack, what are the elements we have? We have only the nodes, whatever nodes are present here. So we are doing the same operation for the n times here. So the time complexity would be order of n for both the algorithm. So that's it, guys. I hope this video was useful to you. If you have any doubt, you can feel free to ask me on the comment section below. And don't forget to like, share, and subscribe. Thank you. I'll see you in my next video.